Today we need to talk about two topics. Both of them should be quite familiar to you from back in Algebra 2. The first topic is polynomials, and the second part will just be working with square roots. You may recall that poly, back from geometry, polygon meant a many-sided figure. So a polynomial is a many-termed expression. However, even though we say it's many terms, a polynomial can be just one term. So this example I have here on the board of x to the fourth minus 3x cubed plus 2x, that should be squared, minus x plus 7, that's what you typically think of as a polynomial. But 5x to the ninth is also a polynomial. Or those lovely binomials we work with all the time. 2x plus 7 is a polynomial. So polynomials can be many types of things, but however, there is one key thing they must have. Polynomials always have powers which are whole numbers. So you can't have a negative power, you can't have a fraction power, it's always a whole number. So consequently here, I'm going to give you a couple examples and ask you, are some of these polynomials? 5x to the 7th minus 3x squared plus 2 over x to the 5th minus 4. Well, obviously, the term we're concerned about is the 2 over x to the 5th. It's a whole number power, but you have to realize it's whole number power in the denominator. If you brought it up top, that would be 2x to the negative 5 power. You can't have that. That's a negative exponent. So no, this is not a polynomial. If I ask you, is 8x to the 10th power minus 5 a polynomial? And yes, it is. One or more terms, whole number power. Now, there's a little terminology that goes along with working with polynomials. And so I'm going to give you an example here of a polynomial. There's a polynomial. We have multiple terms. They all have whole number powers. But that is not what we consider in standard form. Standard form, which is the form we prefer polynomials in, standard form has to go from the highest power to the lowest power. So you have a problem on your assignment which asks you to write it in standard form. So I would have to look through here and go, oh, the highest power is the x to the 7th. So it should start with negative 5x to the 7th. Then we have plus x to the 4th. Minus 3x cubed, or excuse me, plus 3x cubed, plus 2x squared, and then finally the minus 2. That would be standard form, going from highest power to lowest power. Now, once you have determined that, then you can determine two other factors of the polynomial. One is the degree of the polynomial. The degree of the polynomial is simply how high was the power. So this would be considered to be a 7th degree polynomial since the highest power term was 7. The other thing that is extremely important to us later on when we get to a deeper study of polynomials and the graphs is knowing what the leading coefficient is. The leading coefficient is simply the coefficient on the highest power term. So if x to the 7th is the highest power term, then the leading coefficient would be the negative 5 that's in front of it. Okay, that tells us, when we get ready to actually talk about the graphs of polynomials, that tells us what direction the ends of the graph will be going. The 7th degree also tells us how many peaks and valleys will be in the polynomial. So there's lots of good information that comes from just those two factors. Okay, moving onward. Our goal here today, we need to learn how to add, subtract, multiply polynomials. We won't be dividing them till later on in the year. Okay. Subtraction is amazingly difficult. Addition or subtraction. I'm going to hazard a guess your instincts are out there going, oh, well, I need to combine the like terms. But since, in this case, I gave you subtraction, which is trickier. Since it's subtraction, yes, you could sit here and subtract each term, but I'm going to highly recommend instead you change this to an addition problem and go through it, changing all the signs. It'll make less mistakes and get a better answer. Now, it's simply a matter of we need to combine like terms, but we also need to end up in standard form. So we need to figure out what's the highest power term we see up there. Well, the highest one I've seen is the p to the fourth, so I believe we would start this thing with a negative 5 p to the fourth. Are there any cubes up there? And yes, there are. There's p cubed and positive 2p cubed. So if I combine those now, that's going to give me plus 3p cubed. Then I would look for p squareds, and I am only seeing one of them. So I would have just the plus 3p squared. Then I'm looking for any p to the firsts, which I see just one. So I would also then have a negative 5 p that's coming into this. And then last but not least, my constant numbers. And I see a negative 4 and a negative 3, which would leave me with a negative 7. And now you have subtracted the two polynomials and combined the like terms. So that's simply working with simplifying a polynomial. That shouldn't be a major big issue. Okay, multiplication. I've designed a problem here for multiplication that will help us get several different situations all in one problem. It looks like we're just going to FOIL two binomials, but you'll notice the first binomial is squared. And the big question of the day is, what does it mean to square a binomial? And hopefully you're out there going, well, squaring a binomial, that's when we take and means we should take 2m minus 5 times 2m minus 5. And then we'll also have to multiply it by 3m plus 4. So in reality, I'm actually going to multiply all three of those binomials. However, you could only do two of them at one time. And I would certainly square it. Now I'm going to do the squared one by FOILing it out the long way, but we're also going to remember the shortcut that you can know for doing squaring a binomial as well. So if I do that, if I FOIL the first two, I'm going to have 4m squared. Outsides are negative 10m. Insides are negative 10m. And lasts are positive 25. Okay, and that is all still eventually going to get taken times 3m plus 4. You need to combine your like terms before you actually start to do the multiplication again. So those middle two terms would make negative 20m plus 25. Now, I am perfectly fine if you FOIL a binomial and you actually end up doing just a complete FOIL out like I did. But there's also the much easier way to notice what was the pattern when we squared 2m minus 5. You'll notice, in reality, what we did, to the final answer, we squared 2m, which gave us the 4m squared. The middle term was actually what you get when you multiply 2m minus 5. That's negative 10m, and then we simply doubled it. So all you're really doing is taking your two terms and multiplying and then doubling it to get the middle term. And then, of course, the last term came from simply squaring negative 5, we got to 25. So you can do it the shortcut, you can do it the long way, I don't care. As long as you get the flow right, I'm happy. Finally then, the bigger question comes from how do I multiply a trinomial and a binomial together? Once you get to this point, there's no little fun acronym like FLOW. You simply have to distribute. And I would distribute the smaller number of terms, which means I would distribute the binomial. We're simply going to take the 3m times all three terms, and then we're going to take plus 4 times all three terms. It's not hard, just a little bit of writing. So I'm taking 3m times all the trinomial. That'll give me 12m cubed minus 60m squared plus 75m. And then go back and take it all times positive 4, which would give me 16m squared minus 80m plus 100. Then you'll still need to combine like terms and end up with an answer in standard form. So we would start with the highest power, which is the 12m cubed. We have, next we need squares. The squares are negative 60m squared and positive 16m squared. So if I combine those together, I'm actually going to end up with negative 44m squared. Then I'm going to combine the m's. 75m minus 80m is going to leave me with negative 5m. And last but not least, the plus 100 goes on the end. And there you have actually done several different problems at once. We squared a binomial, and we also learned how to multiply a binomial and a trinomial. Moving on then. The last thing we need to do with polynomials is a question that I think you won't have any trouble with. It's just a matter of whether you remember what the terminology means. It's going to say find the conjugate of 3x minus 5 and then multiply the quantities. So the question is, what was a conjugate? We didn't actually use it that frequently with this type of problem, but we actually used it for this problem down here on the bottom right. But we'll talk about it here as well. If you'll recall, a conjugate is nothing more than taking the exact same binomial you've got and changing only the sign in the middle. You don't change the sign on the first term, you only change the sign in the middle. So 3x plus 5 is the conjugate of 3x minus 5. And then they want you to multiply them. Okay? Hopefully you'll recall that when you multiply conjugates, magic happens. Once again, I'm going to do this out with a complete FOIL the long way, but then we're going to remember the shortcut. Outsides are going to be 15x. Insides are going to be a convenient negative 15x. And then finally a minus 25. Well, what happens to the middle terms? They cancel, and that always happens when you multiply conjugates. So in reality, we're only going to end up with 9x squared minus 25. So that's why we love conjugates. They let the middle terms fall out.